If you follow my channel, you may recognize this box. This is the Tometek TC300-TTG. And the interesting thing about this device, of course, it's got 4 SFP plus 10 gig interfaces on it and 2.5 gig interfaces. And this uses the Intel Atom CPU architecture, which is it's more of a server grade hardware that's still energy efficient, like many PCs that are out on the market. And it has some interesting aspects about it. And I had trouble with it in a previous video getting things set up, partially because this device does not have a GPU in it, which helps keep it cooler, but it means you have to access this device with a serial console. Once you figure all that out, I had issues with this device, and it had nothing to do with the hardware. There was a bug in the Linux kernel starting from Linux 6.1 approximately until a more recent kernel version that fixed a long-standing problem. So now this box, I'm going to revisit this because now this box becomes a lot more easier and to use out of the box than when I first messed with this device, which is very exciting for those who have similar hardware to this. So full disclosure, Tometek has sponsored this video and they're interested in seeing a technical demonstration of setting up Proxmox and a few services on top of Proxmox, because they want to study this to see how these types of things work on their hardware that they're producing. So I ended up spending most of the money that they sponsored this video with to upgrade this box, because this device, when I first got it, only has 16 gigs of RAM and a 64 gig mSATA drive in it. So I've upgraded the mSATA drive to a 512 gig to use as for the OS for Proxmox, and then I also bought a 1 terabyte SSD, so I have some storage for the apps. I like separating the boot disk and the apps in Proxmox because I've been bitten a couple times. And I also upgraded the RAM in this to 64 gigs of ECC RAM because the original RAM that came with it wasn't ECC and it was only 16 gigs. I like using 32 or 64 gigs of RAM at the minimum for a Proxmox server. So if I want to run several VMs on top, it doesn't take very many VMs to fill that up. If you give those VMs like 8 gigs of RAM, or all it takes is a couple of VMs and you can fill up all that. So I don't think it's overkill to have 64 gigs of RAM. I think it's a comfortable amount. So in addition to upgrading this system, I bought this little RGB light, so to try to spruce up the background a little bit. I might take this board down. Thought it'd be nice to have it by my desk to use it. Not sure if I will in the videos or not, if I want to draw something up on there. But anyway, I digress, and I just wanted to let you know that this is a sponsored video, but I have full control over the content that's in the video, and it's more of a technical demonstration, a project demonstration using their hardware. I have a link for AliExpress below if you're interested in purchasing this device. It is similarly priced to other vendors that make the same hardware, so it's reasonably priced in that regard. I just wanted to mention a couple little things I noticed when I was trying to upgrade this box that you might want to be aware of, just to be careful with. I noticed on the front with these SFP plus cages, if you're not real careful when you're putting the bottom of the case back on, you could catch one of the edges of the metal on it because it's real thin metal, and you could bend it down and you could just push it back a little bit. It doesn't hurt anything. It's just like real kind of little flimsy because it's real thin where the cage is, but you can just push it back up. I probably wasn't careful when I put the case on, and it's probably my fault for messing that up, but just be careful when you do that. And another thing I noticed, the CPU had a ton of thermal paste on it, which I'm not sure why sometimes manufacturers, they end up putting way too much thermal paste on it. Luckily, it's probably non-conductive thermal paste, because if it was, it probably would have shorted the motherboard out because it was all over the place. And you'll see in the video that I had to clean it up, and after I filmed this, just to make sure it wasn't just all over the motherboard, just in case. I just don't want it to like gum up in there on the motherboard. I don't like having a bunch of extra thermal paste there, so I kind of wiped it the best I could around there. So that's something to keep in mind, because you will have to take off the motherboard out of the case, and one of the RAM modules is underneath the motherboard, which is harder to get to. So upgrading the RAM is a little more of a pain when you want to replace both modules. Another issue I had is the standoffs are so tall that I couldn't get screws long enough to screw the SSD in, so I just used some Velcro. So let's continue with the project. So there's a lot to cover here. I'm going to kind of run through the installation portion a little bit quickly, but I'm going to stop on parts where I think is important to note what you need to do. And I'll talk about it real quick, and we'll just move on to the installation and get Proxmox set up. And then we can set up like something like OPNsense on there, and we can set up like a file server like Nextcloud. And then we can have like a mini PC on the network, and we'll get that set up. Here are the interfaces for the Tometek box. I've labeled what they show up when I do my Proxmox installation, what they are named as. They might differ on whatever operating system you're using or your installation of Proxmox, but the orders should still be the same because that's how they're wired in the hardware, and it's just how the software recognizes the physical interfaces. So please use this as a reference for the rest of the build guide and how you have everything connected, because you can have everything connected ahead of time and you should be able to be fine with finishing out this guide as an example to get playing around with Proxmox on this box. So now I'm connected to the Tometek box with the USB serial console cable. I'm using PuTTY as my serial console client, and I have a USB thumb drive in this box with the Proxmox installer. You might need to set the BIOS to boot off a USB drive or just do a one-time boot off of it. So what we need to do now is go down to the serial console option, and then we'll hit E to edit it. Okay, once you're in edit mode, you just go down to hit Control N to take it to the next line. We'll go down to the Linux line, so keep hitting Control N till you get to the Linux line, and then you do Control F, which takes you across the line. The arrow keys don't seem to work so well in this because it's supposed to be like an Emacs like editor, like it says at the bottom. So sometimes it'll jump you back out if you use arrow keys, so let's not do that. Let's keep going. Let's go until you get past the Prox TUI option there, and we're in between that option, so we'll just hit space, and then we'll start typing no mode set, and then space ACPI, and then underscore OSI equals quote Linux with a capital L. I don't know if it matters or not, but this is the command that Tometek recommended adding to this, so we just need to make sure we use these commands here. We're going to do no resume and console equals TTS. Okay, the only thing we need to add to this console line would be at the very end, so let's go Control F. Once we get past the 115.200, we get to the very end, and we'll type in N8. So we just hit Control X. Now, I mentioned before this section that you just need to connect one of the interfaces. I'm using one of the 2.5 gig interfaces, the first one, to connect to my existing network, because I'm going to show connecting to an already existing network to show how you might want to do this so you don't have to be completely disconnected like I often recommend. I'm just showing you different ways to set things up in my videos. So let's get, I agree. You're going to have this serial console menu, which is not as pretty as the graphical options, but it works. All right, so target hard disk, we need to go up to that, and I'm going to hit enter, and I want to change it because I have two hard drives in here, and I'm going to be using the smaller one for the operating system, and I'm going to use the bigger one for storage for my apps. Okay, so let's pick that. So just pick the appropriate option, and then let's go to advanced options because we want to change the file system. I like using ZFS, even though I'm only using one disk. You don't have to use ZFS. So you want to go to RAID 0 for striping because it's only one disk. And it's going to automatically try to select two disks down here. So what we need to do is go to the first hard disk, hit enter, select our smaller disk, and then go to the second option, hit the down arrow, and then we're going to say do not use. Okay. And that way we'll make sure we only have our one disk. Okay. So let's go to the bottom here. Check some. I think all of those options to the right are okay by default. You can't really see it because of the serial console screen is kind of wonky like that. And then I just hit the down arrow key until I get to the OK button, and then we'll say OK. And then we're going to go to next. And you can set your time zones if you want. I just pick a random one. Let's go down to, we'll just do New York. We'll do make sure I don't hit it too many times because the screen kind of flashes when you use it, which is a little bit annoying, but it works. Okay, English keyboard. So just pick whatever's appropriate. We'll hit next. Now we can type in a root administrator password here. So make sure you pick something good. Hit tab to take it to the next box. Okay. All right. And you can pick a valid email address because it could email you. So I'll just put my home network guy email. So tab tab, next. All right, so by default, it's going to pick whatever domain name you have set up on your network, and it's going to default to the PVE as a host name, so you can change that. And since I already have this interface EMP3S0 plugged in, which is the first 2.5 gig interface, it's automatically picking it up from DHCP. But this is going to set it as a static IP address, but it's going to use a DHCP address by default. But if you manually specify something in here, it's just going to make it a static. So you probably should change it if it's inside your DHCP range, if you're using OPNsense already on your network, or some other router that may not like you assigning IP addresses within your DHCP range. So I'm going to set this to PVE demo. And let's go to the next box. I'm going to set this outside of my DHCP range like I mentioned. So let's just do 2099. And everything else could be the same. Okay. If you're not connected to an existing network, it might default to 192.168.1.1, just so you know. Let's go to next. All right. Now let's go to install. So now the installation's finished and it's auto rebooting. And so now I need to go and take out the USB drive before it reboots. All right, so now it's booting into Proxmox. All right, so didn't take too long to boot up. This system looks like 26 seconds to boot up. It'll take a little longer to finish whenever you start having VMs and containers. It's got also load up, and you'll see that you can access the console at this IP address down here, 20.99, which is what I configured. So from this point on, I'm going to be logging into a system that's already on my network to access this box, because I'm showing you how to do this connected to an existing network, setting up OPNsense and say Nextcloud. All right, so now I have the web browser open, and you're going to get the security risk. See how I have it set to 1.20.99, and you'll see this potential security risk. So we just hit advanced, and we'll just go to accept risk, and it should take us to the login page of Proxmox. So we'll just type in our username and password that we had set. It says we do not have a valid subscription for the server because we're just going to be using the free version. Okay, hit OK. All right, so let's click on the PV demo node, which is the one we just installed, our PVE server. That's what we called it. And you can expand down here, and it shows some other networking and storage pools that you have associated with this node. But let's look at the summary here. You can see this has 8 cores. That's why it says 8 CPUs. And you have 64 gigs of RAM in here. And this is the storage we have on our boot disk. The nice thing about using a virtualization server, we can make better use of these resources. Instead of just dedicating it to a single task, we can put a bunch of things on here and make more use of all of our hardware resources, because we can divide it up between all of our containers and VMs. All right, so let's go to the network section. So here's all of your physical interfaces. The ENO and EMP are your physical interfaces, and then your bridges are going to be named VMBR, and it'll be like 0 through whatever, depending on how many you have created. One thing I want to mention before moving on, I was going to demonstrate this, but it'll just kind of take a little bit of time to show it. But this version of Proxmox out of the box, 8.2.2, doesn't allow for these 10 gig interfaces, SFP plus interfaces, to connect to a network switch. It will only work if you're connecting another 10 gig PC to it directly. But once we update this system, you'll be able to connect it to a network switch just like you normally would with any other interface. That means this Proxmox will work out of the box with connecting to network switches, which is a great, awesome win here for everybody that has these Atom CPUs that are going to be using them for Proxmox. Okay, let's move on to our bridges. So we had the first bridge that's created when Proxmox is installed. This will be used to manage Proxmox. So normally, when I create OPNsense, I think it's convenient to use this bridge as the LAN interface for OPNsense. But if you're connecting to an existing network and you want to try out OPNsense, or maybe you just want to have another network behind it for whatever reason, for lab testing purposes, you would probably want to use a separate bridge for the LAN interface instead. So that way you can connect another switch to that interface, and you won't be interfering with your existing network, because you don't want to have the same IP addresses with multiple DHCP servers on the same networks. So to avoid that problem, we're going to create a separate dedicated interface. And I'm going to create 2 bridges for 2 different networks. And I'm going to plug 2 different PCs that I have with 10 gig interfaces. And I'm just going to test connecting between the two. I'm not going to use a network switch in this video, so I'm not doing a full network build here. I'm just doing a demonstration on how you could use this box with Proxmox. So let's create our bridges. We're going to create one for the WAN is what we're going to create next. So let's call this one WAN, just so we know what it is. I'm going to use the other 2.5 gig interface. Many people don't even have much greater than 2 gig internet, so that's a good use case for using the other secondary or second 2.5 gig interface. So let's call this EMP2 S0. All right, and we'll just hit create. Okay, and then we'll create another bridge, and I'm going to use ENO2, which is our first 10 gig interface. Okay, and we'll just call this 10G1. Okay, and then we're going to create another bridge, BMR3, and we're going to use the second one will be ENO1. Okay, and this will be 10G2. Okay, so now we got the interfaces created. So now what we need to do, we need to upload the ISO image for OPNsense before we create the VM for it, so we can install OPNsense. So if you go over to local, and you'll see there's ISO images section here, and we can hit upload. All right, so I selected the OPNsense image, and I'm just going to click upload. You can add a hash algorithm if you want and to checksum so that you can verify that the image wasn't corrupted, but I'm just going to live on the edge and just upload it. It needs to refresh if I go like that. Okay, yeah. Now we got the ISO loaded. One thing I should do before we move on is I want to store the VMs on a separate disk, because if your main disk fills up in Proxmox, it's kind of hard to recover Proxmox sometimes. So let's go to PV demo. Let's go to disks down here at the bottom. You'll see that I have my storage disk here. If I go to ZFS, because I already used that one disk up, there is no disk available for me to use since I was already testing something out. So let's go back to disks, and we want to go to this 1 terabyte disk. I want to wipe it. I can use that utility there, which is very handy because I don't have to run commands and do it myself. That gives me the ability to now come into ZFS and create a ZFS on this storage drive here. So that's great. And you can leave compression on. It's an efficient compression, so that's great. So we're going to call this app storage and click create. All right, so now we have storage here available. We have that 1 terabyte. That's where we're going to put our VM. So let's go to create VM at the top. And we're going to call this OPNsense demo. But you can click start at boot. If this is going to be powering your main network or another network in your lab network and you want it running all the time, starting at boot is always a good option. So let's go to here. This is the storage, which is local. That's where we put our ISO image for OPNsense. So we just select it here. Someone mentioned to me, why didn't I just pick some other option here for Linux on one of my other videos? Because OPNsense is FreeBSD. It's a good point. Not sure if it makes a difference for FreeBSD, but you can pick other. We'll try that. I think it'll be fine. And let's go to machine. If you're going to use PCIe pass-through, you could use Q35 and OVMF. Those are what's recommended for pass-through. And we can uncheck pre-enroll keys. Someone mentioned that to me in one of my other videos. That way it doesn't enable secure boot, because OPNsense doesn't support that. So we don't need to worry about that. And let's pick app storage, because now we have 2 options for storage. So you can actually disable the local ZFS if you want, if you don't want to have both of them showing up. But we'll pick app storage, and then we got QEMU agent, which gives some extra additional things for the VM, and OPNsense does support that as a plugin for it. So we'll just enable that. So let's go to next. And you'll make sure you have enough disk space. 64 gigs will be plenty. All right, so I'm not sure what's defaulting to IDE. I thought it defaults to VirtIO when you pick the VirtIO SCSI single in this previous one. So that's interesting. So we'll go to disk, and I'll just pick VirtIO block, because that gives you the best IO performance, I believe, for the virtual disks. And discard, someone mentioned if you're using ZFS or something with thin storage, you want to use discard because it frees up space that gets cleared up, so that might make a difference. So we can leave it like that. I think that's all we need for this one. We'll just click next. And for CPUs, I like to do 4 cores for OPNsense. Usually I don't see too much more usage than that for home use, at least on the hardware that I've tested. There's different CPU types here you can do. If you're only using this system, single system, you might want to make this host so it can make use of all of the features. But if you're using a cluster, you want to make sure you pick a type that is the same across all of your nodes. If they're different types of hardware, you may want to go down to host, which I don't know if it's near, okay, at the bottom here. Let's go to next. For memory, let's do 8192, which is 8 gigs of RAM. That should be plenty, even with like ZenArmor and Suricata, those types of things. 8 gigs should be just enough. So you could give a little more because we got 64 gigs of RAM in this system. So now we need to do our bridges. So we have a bunch of bridges set up, but we definitely want VirtIO for these for these bridges to get best performance. So we want to have, let's put them in order of like WAN and then your LAN interfaces just to make it easier. So I already created the bridges in that order. So I'm going to use WAN, and we'll create that as the first one. And we'll do multi-queue. Since we're doing 4 cores, we can do 4 for the multi-queue. So then we'll click on next. And we don't want to start after created because we want to make, add those additional network interfaces so everything's ready to go when we start up. So we'll just hit finish. This takes a few seconds, and this VM should be created. We should be able to go in here in hardware, even though we can't, it's not done yet. Okay, let's go to add, and we'll go to network device, and we're going to add VBMR 2 and 3. So we'll just add 2, and make sure we pick VirtIO because it's not defaulting to that. All right, go to add, network device, VBMR 3, VirtIO. We'll just make sure we enter a multi-queue for all these, and we'll hit add. Now that we have all the network interfaces set up, we can start this VM and go to the console. Okay, so we want to not hit any key for the configuration importer, and we want to go down through. Okay, now we're going to press any key to continue. Because we're just going to manually set these. You could have it auto detect, but we're just going to set them because we know they're in order, so it's going to be easy. Let's hit no. No for VLANs. We're not going to do VLANs. We're just creating separate interfaces because we're going to be plugging directly in. So we're just going to be using the physical interfaces in this example. I'm just showing you different ways to kind of get the setup and test. So you might not want to set yours up this way, of course. Just proof of concept to show what we can do in this box, okay? So we want, for the WAN interface, it's going to be the first one, VTnet0. It should detect all of our interfaces or bridges that we have. So VTnet0, and then we want VTnet1. And VTnet2. Okay, nothing crazy. Then we say enter because we don't have any more interfaces, and we want to proceed. Now that that's done booting, we haven't installed OPNsense yet, but notice it picked up a local IP address. It's the .110 network, which is, this is my lab network. And I had that connected as my WAN to simulate connecting it either to the internet, or maybe you want a lab environment. And so this is your lab network you set up off your main network. All right, let's go and install this. This will be the normal OPNsense installation, so I'll just run through it quick, okay? Let's do installer and OPNsense. Okay, we'll just hit enter. We're not going to use ZFS because we already have ZFS on the underlying host operating system of Proxmox, so it's not good to do ZFS on top of ZFS when you're doing virtual machines. And so you still can take advantage of ZFS features from Proxmox side. You can have all your redundancy and stuff on your Proxmox host if you have multiple drives, which I don't have in this system configured that way. I'm just using those separate drives. So let's go to UFS. And we also don't need ZFS snapshots either because we can just snapshot our VM in Proxmox, okay? So just to keep that in mind. We'll pick that first disk because that's our virtual disk. And wait, yes, yes. All right, so now the installation is done. We can set our root password, which is what we want to do here. Just make sure it picks something good. All right, so now we can hit complete install. And then it should reboot here in a few minutes. Okay, now that's booted up, you'll see a similar screen that we saw before we installed OPNsense, where it shows the WAN interface IP address and then the LAN and the optional interface. You'll see the optional interface is not configured yet, so we will only be able to access the OPNsense web interface from the LAN interface. I'm going to be plugging in 2 separate machines directly into these interfaces instead of using a network switch. So that's one way you can configure this if you want. I'm just doing this for illustration purposes. I'm going to switch over to a box that's connected to this VTNet1 interface, which is our first interface. So now I'm on the client on the LAN interface, and so you'll see the security warning here because it's a self-signed certificate. So let's hit OK, and we're going to type our username and password in here. Oops. I might want to make the screen a little bigger so you can see it. Here we go. And then it's going to take it to the wizard setup. But once it gets to this page, you can hit next and go through it, or you can hit this. It says you can click on this logo, just skip it. So that's what we're going to do, just to take us to the dashboard. You can see we're at OPNsense 24.7. Before we configure that other interface, let's just go ahead and just update OPNsense. You can say click check for updates, and then it'll take us to our status page for the updates. And then we'll go ahead and update OPNsense. It'll be the first thing we want to do. We'll just get this out of the way. All right, so now OPNsense is updated and rebooted, so let's check it out. Let's log in again. And you can see we're at 24.7.6, so that's the latest version as the time of this video. And you can tell they fixed some of the dashboard related things since the initial release of the dashboard, so things look a little nicer here. It looks a little bit crammed on the screen because I've enlarged it. So it's not normally quite that zoomed in. Okay, so let's go to interfaces, optional 1, and you'll see if we want we could name it something different, but we need to go and give it an IPv4 configuration, and we will give it, scroll down, 192.168.10.1, and then we'll make this /24. You'll recognize these steps from my other written guides and videos that I've done. Nothing crazy here. And since OPNsense still defaults to ISC DHCP, that's what I'm going to be using. A lot of people are switching over to Kia, but the OPNsense team says it's here to stay for a while, so I don't see moving anytime soon unless I really need a feature or something, or some kind of security issue or something with the other that's not going to get fixed. Then I think I'll jump over. But if you go to optional 1, let's go to enable DHCP. And we can kind of copy and paste this, make the range similar to what the defaults are, which is 100 to 199. I'm just using this for demo purposes, so it doesn't really matter. Okay, and we'll just hit save. All right, and then one last thing we gotta do, you always have to do 3 things in enable an interface, right? You gotta assign the interface, you have to give it DHCP range, and then you have to update the firewall rules because there aren't any by default. So let's go to rules, and we'll go to, let's go to LAN. We'll clone it just to make it easy. So we're only messing with IPv4 in this, just to keep it easy here. And we are going to change the interface to optional 1, and source, we want it to be optional. We start typing it, 1 net to any. So we're just doing any to any, just to demonstrate how this works together. You definitely don't want to leave everything wide open for your actual network. But one other thing too that we need to do, if we go to Unbound DNS, I'm going to enable query forwarding on this because I want to use the name servers here and hit apply. Since my primary OPNsense box is set up to forward queries to a specific like DNS server, since I'm using DNS over TLS, I feel like it interferes with the recursive resolver getting to the root servers. So if you just say use query forwarding, and if you're doing a router behind another router, and you just forward this to the lab network that I'm on, this for example, then it'll work just fine for all your clients on your network. That'll save you maybe some headaches with some DNS later on, just for testing purposes. All right, so let's go back to DHCP v4 and leases, and let's see if we have our other client on the network. Okay, so it looks like it came online because this was my 10G client 1. The other box is the 10G client 2, so it picked it up the changes that I just did. All All right, one thing we could do for fun is do a speed test. So I have an iPerf running on the other server or other client, I should say, and then I'm just gonna do this. This is without any performance tuning on OPNsense and a VM, and you're gonna see you're not gonna get 10 gig performance between the two interfaces. Just the speed of, the fact that I'm using bridges. You can see I'm getting about 2 gigabits per second, a little bit above it, like 2.3 gigabits per second. So it's still definitely above 1 gig, but it's about the same speed as a 2.5 gig interface. Those speeds could be disappointing, or you might be okay with these speeds to get 2 gigabits per second if you're not planning on transferring a lot of data between networks. I just want to mention before continuing that even though OPNsense seems to get about 2 gigabits per second in a VM with no additional tuning, and about 3 gigabits per second bare metal from a previous video that I tested this out, that you can still get about 10 gigabits per second on this interface whenever you're using the interfaces directly on the Proxmox host, or Debian or Debian, however you pronounce it, server, or an Ubuntu server, another Linux server. Those sorts of using the host in the interface directly seems to yield 10 gigabits per second performance. And I want to show you that quickly. This is a quick test to verify that. I'm going to use EN04. I manually configured the static IP address for this interface, which is the third interface to the right of the SFP Plus. You have to, one thing you need to do, you have to enable auto start here, because when you create bridges, it automatically has auto start checked. But when you're using the interface directly on the Proxmox host, you need to check the auto start button, because it doesn't do it for you. And I just manually put in this IP address 192.168.1 or .99.10. This is my static IP address, and then I created a static IP address on my other system that's connected to this, and I made it .11 in the same subnet. So what I'm going to do, I'm going to jump over the shell, and I'm going to start a iPerf server instance right there, and I'm going to switch over to my PC now. And I'm going to run my speed test, and we'll see that we get 9.4 gigabits. It's basically the theoretical max, unless you use like MTU 9000. You can, in jumbo frames, you can get a little bit more, maybe like 9.8 or 9, something like that. But you see, I get a full 10 gigabits per second. I'm using the interface directly. All right, so now I'm running a speed test the other direction to show that I can get 10 gigabits in the other direction. So you see 9.4. I'm getting pretty good there, full throughput. There's just one more thing I wanted to mention that Tometek told me with the Debian Linux that they notice is different than Ubuntu. Ubuntu has a package called IRQ Balance installed, which improves performance on this box for Ubuntu installations, but Debian does not have that installed by default. So I noticed it does affect performance, where I've seen people say they get performance at 10 gigabits one direction, but the other direction only get like 4 or 5 gigabits. You get like half the speed. So if you want to improve the performance of the host interfaces when you're connecting to it, say to a storage 10 gig network or some other network, you might not see the benefits necessarily in a VM. Possibly you'll see it in a container, but because as we've seen with OPNsense, it depends. If you're doing Linux container, you might see the full benefits. So what you need to do is do apt install IRQ balance, okay? Which it says I'm already using that. So that's something that doesn't seem to negatively affect Proxmox, but that's something that you might be able to do to get some extra performance. Before we continue on, I forgot to update the Proxmox, so this will allow it to work with the network switches. So what we're going to do is we're going to go to the shell. I'm going to use the Tech scripts for Proxmox just to make it easy. You could do this manually, but I'm just going to do this for the purpose of demonstration to show you what the script looks like. It says go ahead and do this. Hit yes. And we want to correct the Proxmox sources. We'll hit yes. Disable, yes. And I'm just hitting the enter key. Enable the no subscription repository. We hit yes. Correct the Ceph package sources. We can hit yes. And then add the PV test. I usually hit no on this one because I don't really care about the test repository. I just want to use the main one. Disable the subscription nag. We'll hit yes. And it says please support the team. So we got that. Okay. We don't want to disable high availability just in case you want it. But if you're just using a standalone, we could just say yes. I'm just doing this for demo, so I'm just going to disable that. It just frees up more resources, and it might even decrease wear and tear on your drives if it's not logging a bunch of stuff in the background. So let's update Proxmox VE now. Wait, yes. So now we just wait for this to update. And we should have the latest Proxmox, which allows you to connect these 10 gig interfaces to network switches, so which is important, I think. All right, so now the system's rebooted, and you can see our Linux version is now 6.8.12-2. So now let's create a container, but before we can do that, we need to add a template. So we need to go to local CT templates, and we need to click on templates. And you should see a bunch of templates in here. I had to run a command called pveam update, which updated this container list because for some reason it didn't do it when I did my update. If you run into that problem, you can run an update command and it'll update this list. It didn't have Ubuntu 24.04, which is the latest. So that's what we're going to select is Ubuntu 24.04. You can use your container of choice. Ubuntu is not the lightest weight, but I like using Ubuntu, so just what I'm familiar with. So let's click on that and you should get a quick little download there. This allows you to have a template to work from. You have to have at least one template to create a container. So that's one thing you need to do first. So let's just call this Nextcloud demo. We're calling everything -demo is the host name. And we're going to put the password in here. All right, that's the minimum amount what we need to get this going on here. So let's go to next, and we're going to pick our template that we just downloaded from the local storage. Hit next, and we can give this whatever, how much space you want, 20 gigabytes. If you're storing the data in this container, then you definitely want to allow more disk. But what I'd recommend doing is creating a separate file server. Like if you have like a TrueNAS box or something, you could mount that and use this in the container. But I'm not going to go through all that. So let's go to next, and we'll just do 2 cores because Nextcloud doesn't use a whole lot of processing. So let's do 2 cores, and for RAM, 2048 would probably be okay because I noticed in my VM it uses maybe a little over a gigabyte. So let's go to next, and we're going to select a bridge. Now that we have all these bridges defined here, this is one advantage of using bridges versus PCI pass-through. We can use the same bridges as we are for interfaces. Since this is the LAN, we can pretend this is 10G1 is like our management interface, and we'll say this is whatever IoT or DMZ or whatever. So we'll put it on VBMR3 for an example, and we will do DHCP for IPv4, so it'll get an IP address, and we're not going to worry about IPv6 here, and we'll go to next. Because we're on that network for the .10 network, we don't want to use the host settings because the host settings, remember, is 192.168.20.1 is what it'd be using. But since we're on a different network, we're not going to have access to that DNS server. We're going to use the OPNsense DNS server that's on the 192.168.10.1 because that's a network that this container is going to be on. Okay, so hit next, and we can go ahead and start this after creating it. This takes a second to generate SSH keys and to get started. And one thing I forgot to change because the option isn't available until you go into the options here. If you click on the Nextcloud demo, go to options. We're going to need, because I'm just going to do a quick setup of Nextcloud. I'm not going to do like a manual installation like I've done because I feel like it works well, but it takes more time to get the initial setup, and after that you can just update it like normal. But we're going to enable in these options here, we're going to enable keyctl and fuse, because I'm just going to use the snap package just for an example. I don't necessarily recommend the snap package. It's maintained by the community, but it does seem to work for a quick little installation for us. And we're going to have to like shut this container down. I should have not started it. I forgot about this option here until after I started it. Now we can start it up when we'll have these features enabled that we need. This is the same things you would need to enable if you're using Docker inside a container, which I don't really recommend. So let's go to console. And this will be the username and password you entered. Apt update, and we're going to update and upgrade this first just to get this container up to date. And this, once you're in here, it's almost as like you're on a standalone system. It's just going to have the same like Linux operating system command lines for Ubuntu. You see there's 120 packages need updated, so there's a lot there. So we'll just do dist upgrade. All right, so one thing we can do is dpk, I always like doing this, dpkg reconfigure. If I can type, reconfigure, TZ data. You can set your time zone. So we can say Americas. We're going to just set it to New York for the fun of it. Okay, now it sets the proper time zone. And we can reboot this because it says it needs to reboot for some of the updates that we had. And since this is a container, it reboots really fast compared to a VM, which is really cool. And basically, it's almost done already. We just need to log in. And if you have a faster system than this box, it'll go even faster for the reboot. Log back in. So now we're going to need to install snap D, the daemon for snap packages. So we'll do apt install snap D. All right, now we can do snap install Nextcloud. Try it again. All right, so now it says snap is installed. I've noticed this before. Last time I was just trying to set up a demo with Nextcloud, I had to run the install command twice because maybe something wasn't loaded properly or something, but at least when I ran it the second time, it works okay. So now let's log in from our client machine that's on the same network, and then we'll also try accessing it from the one that's on a different network interface. So let's see what the IP address of this machine is, just so we know it's .10.101. So now I logged into 192.168.10.101, and it says create an admin account. It'll be prompted with this the first time you install it. Notice we don't have HTTPS set up with this configuration. You could put this behind a reverse proxy or do other configuration to get that set up, but out of the box it doesn't have that. Let's do admin. Very original name, right? And we'll click install. Okay, so now it's recommending some apps you can set up. If you don't want any of this stuff, you just want basic files sharing, you could just hit skip on this so that it just makes it a little quicker to get into it. You can always install it later. And now there's going to be a little demo here of what the features are, a little screen here. And you can hit next, or you could even close this out really. And it's going to give you this by default, this dashboard. You can customize this to show different things. If you had different plugins installed, you can have different screens here. If you do the default installation, there's like 4 or 5 tabs that are up here that you can look at. But if you can click on files, you can see they put some fake default files in here for you, some example files, some readmes and different things to show what it looks like to have some files in here. Now let's jump over to the other system, see if I can access this from a different system. All right, so now I jumped on the other system, and you can see I can access the web interface. You can see I have my OPNsense windows still open for there. Not now. Yep, and I can get in just like I could on the other system. Let's go back to the Proxmox screen here, and we can look at how much resources we're using on the system here. And you can see, we're only using 10 gigs of RAM, 1.5% of the CPU because it's idling. If we put IDS IPS on OPNsense and there's a lot of network traffic going through, you could definitely push that up to maybe 30, 40, 50% of the CPU with just the one VM. But you can see how even this little box, we have a lot of room here to grow and do stuff with it. I hope you found this video with the Tometek TC300-TTG to be interesting and informative on how to set up like Proxmox, for example, and some services on top of that. And I'm just glad you stuck around for the ride because this had a lot of information in it. But I think it was interesting to be able to show these kinds of examples. So until next time, I'm Dustin Casto, signing out.